The mean time it takes to service 46 customers at a drive-through fast food restaurant is 165 seconds. Use StatCrunch to find a 98% confidence interval for the mean if the sample standard deviation is known to be 15 seconds. Okay, so in this problem, we're going to determine a confidence interval. In order to find a confidence interval, we need two things: the best point estimate and the margin of error. The best point estimate in this case, since we're determining the confidence interval for a mean, is the sample mean. So in this case, our sample mean, x bar, is going to be 165 seconds. Next, the margin of error we have to determine using a 98% confidence level. So in order to find that, we're going to need our formula. Our formula from our formula sheet is going to be E equals our T critical value times S divided by square root of N. So to find our T critical value, we're going to use our chart, our T chart, and it is located in your course content. So to figure out our T critical value for the 98% confidence level, so 98% confidence level and our T critical value, the first thing that we have to do is in our T critical value, it's based upon what's called degrees of freedom. So our degrees of freedom is going to be n minus 1. So our sample size minus 1. Since our sample size is 46, 46 minus 1 is going to be 45. So our degrees of freedom is 45. On our chart, we're going to have to look at the degrees of freedom, 45. So we're going to go to 45, and notice some of these skip around. So what you're going to have to do is some of these should be, most of them should be on the chart. If it's not, you're going to have to go to the next closest one. Fortunately, I've done one that is on the chart. So we're going to use 45 as our degrees of freedom. And notice at the top it has level of confidence. Our level of confidence in this case is 98%. So we're going to be looking in the 45th row and 98%. And let's see, our critical value is going to be 2.412. Our other information we have to know is S and N. Well, we already said N is going to be, let's see, N was 46. And S, our sample standard deviation, is given as 15 seconds. So let's substitute all of those into the formula. So our formula is now going to look like this. E equals, our T critical value is 2.412 times S, which is 15, divided by square root of 46. Entering that on the calculator, I'll write the directions down here. It's going to be 2.412 times, open parentheses, 15, divided by square root of 46. Some of you might need to put parentheses around the 46. Close your parentheses for that operation and hit enter. So I'll pull up the calculator and do that. Let's see. 2.412 times, open parentheses, 15 divided by square root of 46. I'll put the extra set in, arrow out, and close the parentheses for the operation. Hit enter. Our answer then is going to be, our margin of error is going to be 5.334449974. And so don't forget, our sample mean is 165 seconds, so our margin of error is going to be 5.33 seconds as our unit. Now let's put it all together to construct the confidence interval. Our continue problem says construct the 98% confidence interval for the mean time it takes to service customers at the drive-thru. Our general formula for our confidence interval is going to be our sample mean minus our margin of error. That's our left boundary. And our right boundary is x bar plus our margin of error. Remember, that's going to determine the range or the interval for the population mean mu. We've already calculated out the sample mean to be 165 minus our margin of error. And our margin of error from up above is 5.33, and I'm not going to round here, 4449974. So that's our lower boundary. Our upper boundary then is taking our sample mean, 165, and then we're going to add our margin of error now again. 5.33, 4449974. Let's see how this looks on the calculator. So 165 minus 5.33449974. Hit enter. And our lower boundary then is 159.66555. And our upper boundary, so we use the calculator again. I can type in the same thing except go to addition. 165 plus 5.3344499974. Enter. And our upper boundary is going to be 170. Sorry, let me get rid of this. It's not going to get rid of 170.33445. Here we go. So remember, these are going to be in seconds. So our sentence, let's see how our sentence is phrased. Our sentence is going to say we are, and we got to state how confident we are. So we are 98% confident the population mean, we have to say population because we're doing it for the population here. We took our sample data and we're estimating for the population. Mean time it takes to service customers at a drive-thru is between, and we can state our answer. We're going to round to 2 decimal places. So this is between 159.67 seconds and 170.33 seconds. So don't forget, we're not calculating the actual mean time, we're just calculating the range in which, or the interval in which it would happen, okay, with how confident we are. So let's double check our answers on StatCrunch. Remember, StatCrunch will provide the confidence interval, but it will not provide the margin of error. So on StatCrunch, our directions are going to be under Stat. Then we're going to go to, because this is a mean, we're going, and with the standard deviation known, we're going to go to T-Stats and one sample. I'll write those directions down. T-stats, one sample, and we're going to go with the summary. So those directions again are, we're going to go to stat, then we're going to go to T-stat, then we're going to do one sample with summary. Now let's enter the information that we need to have here. So in our problem, our sample mean we said was 165. Our sample standard deviation was 15. Our sample size was, remember, 46. And we're going to do a confidence interval for the mean. We're going to change our confidence level from 95 to 98, so make sure we adjust that. And we go ahead and hit compute. After we hit compute, we can see our sample mean. We can see our degrees of freedom is 45 there. And let me see here. I might have to pull it over a little bit more. And we can see our lower limit and our upper limit. So let's notice our lower limit. We calculated our lower limit to be 159.66555, and StatCrunch considered our lower limit to be 159.66529. It's a little off, but it is the same answer to 2 decimal places. That's why I rounded to 2 decimal places. So be aware of that. Because we're using the chart, it gives us a little bit of a rounded error at the end. But either answer would be acceptable to me.